This model-driven engineering is early stage development process it is, and we are not sure that it is going to be works properly for the project. Still, the advantage of this is allows the systems to consider the higher level abstraction. Programs, you are not directly writing the program, so you will be going to write the abstract notation of the model that you will be going to write it in this. So you can analyze, basically you can understand that how that it is going to work, and you will be going to generate the code automatically in the system. That some of the programmings are going to there, technology is going to be there, so that automatically it is going to generate the code for that. Okay, that is going to be cheaper, but it is not going to be long lasting. Okay, then problems are going to be model is as it is abstract, and implementation we cannot be able to sure that it is going to be successful one, but it saves in the form of coding. Okay, so generating the code, it is going to work properly or not, that also we will be not sure about that. The cost is going to increase because of these things. There are different types of models are going to be there. One thing is that computational independent model, that is CIM, computational independent model, means these are going to work with the individual models. It is going to be individual models, individual domain, specific domain that it is going to work. The abstraction of the programs will be there, and it is going to work in that particular model. Independent model, that is PIM, platform independent model. The operations of that program, that it is going to work in the different platforms. It should be referred, and it should work in the different platform. Like that, the programs will be there, or model will be getting executed. So as a model is in single model is going to be there, that it is going to get executed in any different platforms. Like that only you should write the programs. Next is platform specific models. This is one of the important thing it is going to be. Okay, so some of the programs, I'll take the example of that web programming, where you'll be going to write one HTML program which it is going to run only in IE, that is Internet Explorer, but the same program is not going to run in another platform like Mozilla. Okay, then you'll be going to have other browsers, that it is not going to work. Reason is very simple. As a platform it is came, Microsoft, it is going to work in the only in the Microsoft related softwares that programs are going to work. The Java related things, okay, it is going to work in a different environment. Linux platform, there are so many platforms will be there, depends upon the programs. Okay, some of them they are going to give the platform independence, and some of them they are not going to be addicted with the same platform. Okay, so platform specific models are going to work in particular platform only. How this transformation takes place, basically, okay, between the model-driven architecture. So you can see that here computation independent model is there, which is the domain specific guidelines will be given to the translator. So it is going to check with the independent model, and according to that it is going to execute, as well as the translator is going to translate that information to the platform independent model. Computation model is different, and in platform independent model is going to be different. Now so many independent models will be there, those things are going to get executed. Next, that platform, the accepted platform, is going to translate, given to the translator, to the specific model, the platform specific model. Here what happens basically is platform specific patterns and rules are given to the translator. According to that, it translates and gives to the platform specific model. This model again gives to the translator to execute the code. So for this, the language specific patterns are going to be there. That language, if you want to write, and it is getting converted in the form of some particular code, where that code is going to get executable in any other platforms. So Azure code is getting created for that. Different multiple platform specific models. Now you see that's what I said. There are two divisions. One is a J2W translator and a .NET translator. Down whatever that you'll be going to see, this is a Microsoft products it is going to be. Okay. Other things it is going to be another product. Platform independent model. There are two different models are there. One is a J2W translator is there, and here is a .NET translator. J2W translator specific model, J2W only. Then Java code is getting generated, bytecode. Then Java program is going to execute. .NET translator, .NET specific model is going to be present. Then C hash code is getting generated. C hash programs are going to be get executed. Okay, so basically it is a multiple platforms or multiple specific models are going to execute in their environment. Next is the context model. Context models are used to illustrate, means to tell the operational context of the system, which environment that it should work. Okay, and the boundaries are going to get specified in this. Okay, nothing but again same concept. What I'm saying is the previous thing that we learned is a specific platform. In that particular platform only, in that boundary only, that your programs are going to run. Okay. Then social and organizations concepts will be there. That's what organization is. Microsoft is one organization. Okay. Then Linux is another environment, platform or organization. So those are going to be worked in that particular different environments. Then architectural models shows the system how it is going to be related to each systems. So architecture diagrams or models that we are going to specify says that which system that it's going to work for which environment. So what is the relationship between both functions as well as the programs that it is going to be specified in the architectural models. Always the boundaries are going to be mentioned in this system boundaries. System boundaries are established to define what is inside and outside the system. Means any programs are going to be whether it is dependent on the previous program or not. You might have already studied or you'll be going to study about the Linux environment. Okay, Linux programs that you'll be going to study. There's one function called a pipe. Okay, it says that one program's input will be given to the one program's output will be given to the input to the next program. Unless the previous program works, gives the proper output, we cannot able to give the input to the next program. So the boundaries have been fixed in this. Okay, so it should work first, then only we will get the next. System boundaries are going to be mentioned. Okay, so the restrictions are going to be put only this particular environment your project is going to work, that it is being specified. And there are so many constraints also going to be there. There's boundaries or constraints that you can tell, political judgments and political influences, and where exactly that you'll be going to get implemented, what is the environment positions over there. Based on all the restrictions, the boundaries have been set. Here in the Mentcare system, the context of this is how this works basically, what for that it is going to be. So in the Mentcare system, this is the main program it is going to be. So all things are getting communicated in this. First thing is that management reporting system, that is one. Then patient record system, admissions system, prescription system, appointment system, HC statistics system. Now you see one program, that is nothing but a main system, that is Mentcare is a system, but there are so many other contexts of the Mentcare systems are going to be present here. All these things are individually that it is going to work, and combined also that it is going to work. Okay. The activities are going to get executed in the these activities that